Welcome back. In this lecture, we'll be introducing frequency distributions and histograms. When you get data, the first thing you usually are going to want to do is explore it. There's two reasons you want to explore your data as soon as you have it rather than jumping straight into analysis, even if you think you know what you're doing. One, getting to know and understand the data will help you see if there's unusual structures or unusual ways that things are coded that may cause trouble. It'll get you a sense of what the data look like, what the distributions are, and thus what might be the most useful ways to think about it. Second, you can actually detect things that are really important to know before you do analysis. You can find out if there are errors, potentially. You can look for outliers, that is, observations that are really different from anything else. And you can look for, in addition to errors and outliers, you can look to see if there's missing data and whether it's coded so that you know if it's right. We'll go over this more in lab, but for the moment, let's just take a look at a simple frequency distributions based on this data here. This data is data on my step-siblings. I'm an only child, but my parents both remarried when I was about 10, each of which came with siblings. If you're interested, the top 6, 7 here came from my stepfather. These two came from my stepmother. I saw them on weekends. I lived with these ones, except for the top two, who were already adult by the time that my stepdad remarried. So in this chart, we've got their name. It's basically an ID number, right? Their gender, their age at the time. You can see here's me, I was 10 years old, and their closeness to me. You've noticed I've coded closeness as a 9 for myself because I really don't want to code how close I am to myself. Instead, I've coded that as a missing data code. We'll talk about that later. For now, let's take a look at gender, and we'll include me in it. So, to make a frequency distribution, which is a way to summarize the counts of the different possible values, we need to know all the possible values. So, we have male, female, trans male, and although we don't have any cases with it, trans female is still a possible value. So we're going to go ahead and put it in the chart. This first column, frequency, we just count up how many of them there are. So there's 1, 2, 3, 4, 5, 6 males, just 1, 2 females. Lyle is the only trans male, and trans female, 0. So far, so good. Cumulative frequency is pretty simple too. All you do is you add up all the frequencies so far. So 6 is 6, 6 plus 2 would be 8. You can either add up all the ones in this column over and over, or you can add the last cumulative frequency to the new frequency. This is 9, and still 9, because we're adding 0. If you notice, cumulative frequency should add up to the number of cases we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Now, let's complicate it a little bit. Let's convert those frequencies to proportions. We know there's 9 cases, so each case should be about 0.11 of the total. So if we have 6 out of 9, that's 2/3, or 0.67. 2 females would be 0.22. 1 trans male is 0.11, and this is 0 for the proportion. You could convert that to a percentage too. 67%, 22%, 11%. The only difference between a proportion and a percentage is you move it over. Percentages are sometimes easier for people to understand who are lay people who don't speak statistics. It's hard to read, but this is valid percent. This is almost the same, and in this case it actually is, because all of these are valid. So that's going to be the same. The difference with valid percent is that if you have missing data, that'll still count in this overall proportion or percentage, but it won't count in this valid, which is usually the number you want to use, unless you're including that missing data, those cases with missing data, in some other way. So I've also added cumulative valid percentage. You do this the exact same way as cumulative frequency, except valid percentage. So we take 0.67, we add that to 0.22 to get 0.89 here. We add 0.89 to 0.11 to get 1.0, and we add that to 0 to get 1.0. This should always be 1. This lowest number on the cumulative frequency should always be the number of cases. The lowest number on the cumulative percentage or cumulative valid percentage should be 1.0 or 100%. Now, what if we were to make that into a histogram? In the case of a nominal variable like gender, it's just a bar chart. We've got male, female, trans female. And if this is 2, 4, 6, then our male bar would go up there, our female bar would go up here, trans male bar just goes to 1, and there's no bar for trans female because it's 0. Now what have you gained by this? Well, you can see it visually, which helps a lot of people. You could also easily organize them if you had more categories, from most to least frequent. You could do a variety of things, right? You could also convert this to proportions. So instead of frequencies, if we wanted to do this as a histogram of proportions, we could say this would be 0.67, or say better, 2/3. Then this would be about 1/3. And we would read that then as 0.67, or 2/3 of the cases are male. 2/9 of the cases, around 0.22, are female, and so on. This is less useful with small numbers, but with big numbers it can be useful to switch to proportions. Now let's try this. We've done this with the nominal variable. Let's erase and switch to ordinal. Closeness. Closeness is on a scale of 0 to 5. 0 meaning I've never met them, I have no idea, I'm not at all close to them. Cumulative proportion, valid proportion, cumulative valid proportion. Okay, and so now for closeness we have values 0, 1, 2, 3, 4, 5, and 9. Put an extra bar there to denote that 9 is a missing data. Okay, so that's missing data. So how many cases we can do frequencies the same way, right? Closeness, we have 1, 0. We have 1, 1, 1, 2, 3 2s, 1 each of 3, 4, 5, and 9. So already from the frequency we can see, right, that the most frequent, the mode, is 2 closeness, or not particularly close, but at least I'm around them fairly often and I see them and interact with them. If we were to do cumulative frequencies, same pattern, right? 1, and then we add this plus that to get 2. We add this plus that to get 5, 6, 7, 8, and 9. This number, again, is the same as the total number of cases. That's a check that you're doing it right. For proportion, same thing. There's 9 cases, so again, 0.11, so 0.11, 0.11, 0.33, 11.11, 0.11. Now, valid proportion, we've got missing data, so this is going to be not included in those, right? This 9, that's missing data because that's me and I can't be close or not close to me. I'm just there. So the valid proportion then is out of 8 instead of 9, so this is going to be 0.125. If you have no missing data, that'll be the same as the proportion, but 0.125, 0.375, 0.125, 0.125, and then we can fill out the cumulative valid proportion. We do the same thing, so this is the same as for the first level. For the next level, 0.25, 0.575, 0.25, 0.75, 0.875, and 1.0. And again, we check the cumulative proportion or cumulative valid proportion is 1.0. If we did cumulative proportion, the 1 would be down here in the missing. So histograms become more useful in this. Histograms become more useful because now we've got an ordinal data. We can, if this is 0, 1, 2, 3, oops, it's not 3, 3, 4, 5, this is still frequency, or count, but this is closeness, and it's actually on a scale now. We don't know that the distances are the same, but we can use the histogram to evaluate. So we've got 1, 2, 3, 4. So that's 2. So that would be 1, 1. In our case, it's not too interesting because everything's the same except for the 1. But you can see the difference. And in fact, if we were to superimpose a normal distribution, which we'll talk about later in the second lecture, it would look something like this, and it actually would not be too far off, even though all of these are the same except for that. It's just that the distribution couldn't be split quite the same. So a histogram with an ordinal variable is much more valuable. And in fact, that's probably the case where it's most valuable than with a nominal variable. Otherwise, it's just a bar chart. Now, last case, we're going to do age, but age is an interval level variable. And if we were to map out every possible one, we would have to have, even just for the range here, we'd have to have about 18 lines. And it wouldn't tell you much because each one would only be 1 except for this 1 year of 10. So instead we're going to combine. We're going to put 0 to 9 here, 10 to 18, and 19 plus. I chose these because 9 is younger than I was at the time. 18, under 18 was still living at home, and 19 plus was not living at home. So we can collapse these categories. If we look, we have, these are handily in order already, so we've got 1, 2, 3 that are 0 to 9, 1, 2, 3, 4 that are 10 to 18, and 2 that are older. That's the frequency. We could do cumulative frequency, 3, 7, 9, again we're up to 9, proportion, invalid proportion, and so on, just the same as you would for an ordinal or nominal variable. But with the histogram, we have to make choices. I've already made choices. If I have this whole data in front of me, right, I could chart each one. We could have this be 3, 5, 7, 9, 11, 13, and so on. And we would have 2, 1. And we could chart, okay, so we've got a 6, we've got an 8, 9, oops, that's actually going to be 2, the way I drew it, and so on. But it doesn't really tell us much because it's so spread out. Instead, we do what's called binning if we want a histogram for an interval level variable. So we do exactly what was up here. In this case, we'll say 0 to 9, 10 to 18. We could choose a different size of bin, and it would look different. And it's up to you to figure out what works the best, what tells the story of what matters about the data the most. But here, if we say 1, 2, 3, 4 frequency, then we could put 3 in that category, 4 in that category, and 2 in that category. And we've told a story that there's a number younger than me and a little bit more older than me are actually the same, because you figure that this last one is actually me. So I've got about the same number of siblings, younger than me and older than me, that are still living at home, and less, but some, that have moved out. So that's all for frequencies and histograms right now. We're going to talk more about it together with normal curves and other kinds of distributions and looking at the characteristics of these frequency distributions in the next video. Thanks for watching.